All right, here we go. What I want to do is talk to everyone about what's new in Neo4j 3.4. This will be a quick webinar. I'm scheduling it for about 30 minutes or so. So Neo4j 3.4 is a brand new release that came out last week. It includes a variety of new capabilities. So let's start going through them. Of course, you know Neo4j, who we are, the core creators of the Graph platform, known as our native Graph platform, and we're growing quite well and very, very healthy. And many thanks to all of you out there who are helping contribute to that growth as being members of the community. We're the Graph platform company. Back in October, we announced and have been bringing forward this notion of a Graph platform that incorporates all of the technologies required around the software engineering lifecycle in development, in integration, in supporting a variety of database use cases, including transactional use cases and analytic use cases, and then helping to visualize as well as build applications around the original Neo4j database. Of course, our mantra is ACID transactions all the time, supporting global scale, and really highly promoting the ideas around graph adoption. The innovations that we've come up with recently, if you look between the 2017 to end of 2018 kind of timeframe, areas where we are investing is, as I just mentioned, rolling the first Graph platform. We also added Graph algorithms to the environment. We added Neo4j Desktop. I'll talk about that in a second. And then now we have going on an early access program for Neo4j Cloud. I'll talk to you about Neo4j Bloom in just a moment. We released earlier this year Cypher for Apache Spark. This is a toolkit in the open source world for putting Cypher on top of Spark itself. We did the same thing for running Cypher on top of the Gremlin engine. So you can see that we're really driving towards kind of universally promoting Cypher as a vehicle to wrap around the Graph world. And the GQual manifesto that is also listed there, I'll talk about in a moment, is another example of this, of promoting a common universal Graph query language that can be supported across multiple products. And then towards the end of the year, we'll start to introduce even more new capabilities. The Neo4j Cloud will roll itself out. We've been promoting the idea that Graph itself in the database space is a unique paradigm that I believe as well is taking foot. So the platform, as we rolled it originally, was designed to support two common themes. One, support the idea of delivering more product functionality around the original Neo4j database, as well as serving a variety of different user communities around the database, from the developers to different types of applications, supporting the enterprise data hub and those folks who are performing data integration activities, fortifying our support and activities around graph analytics for data scientists and analysts, and then of course supporting line of business folks. So this notion of enabling the connected enterprise, we look at this from the standpoint of building transactional graph type applications. These are what many folks are familiar with from Neo4j, creating recommendation engines, fraud detectors, network management capabilities, knowledge graphs, etc. We've seen an emergence of the artificial intelligence and graph analytics space. This includes logic behind sentiment analyzers, logic behind customer segmentation. Cognitive computing is oftentimes looked at as a graph type activity. Community detection is another great example of where and when to use the graph algorithms that we've delivered. And then finally, for business users, helping them understand and kind of have their own graph epiphanies, whether that's recognizing that When you're looking at fraudulent activity, fraud activity has a shape to it that oftentimes people don't realize until they actually indeed see it. Looking at product information, looking at risk analysis type and risk management type activities. These are all areas for supporting business users in their adoption of graph capabilities. And earlier, let's see, about a week ago now, we came out with the GQual Manifesto. And what this is, and you can still read about it at gqual.today is where the original manifesto lives. And what this is it's an initiative to rally support for a unified graph query language. And what's really interesting about this activity is that this unification activity that we've been promoting at the beginning of last week, this is only a week old, the notion was to combine the great things about Oracle's PGQL, the G-Core work from the LDBC standards body, and Cypher, combine all of those together into a unified query capability that supports things like composability. So the idea that a graph can query a graph, can query a graph, can query and deliver a graph, those kind of things, or support path-based queries through the graph. So this started out as an activity built around rallying support in the standards bodies. And what's happened even since then is we've gained support from the LDBC community directly, and that has been recently re-ratified at the most recent OpenCypher meeting that happened a couple of days ago. And even the folks at Oracle are in support of this activity as well. And we've actually been running a market supporting thumbs up, let's say, kind of vote for your approval or encouragement or disapproval and discouragement of this activity. And if you go to the gqual.today URL, you can not only read the manifesto, read the letter that we put out to all of the participating vendors, and vote whether you are indeed in favor of this activity or not. And we'd appreciate that feedback. So let's move into what we've been building in the product itself. The latest things that we put into the product, I'll do a very brief review of Neo4j 3.3. And this really sets the stage for how we've been building the scaling capabilities, the performance investments, things of that nature inside of Neo4j for quite some time. Most recently in 3.3 in October, we came out with multi-data center clustering with secure transit from server to server. So this allowed us to operate across a WAN and support multiple data centers or multiple data center zones, those kind of things, using the causal clustering capability in Neo4j Enterprise. We came out with Neo4j Desktop. This is the launchpad for developers to jump into Neo4j, and this continues to get fortified and adds capabilities. I think you'll now see that it supports the APOC libraries, it supports the graph algorithm libraries, it'll automatically install those plugins to your environment, it'll update and refresh your Java environment as you need, and keeps you completely up to date with all of the inner workings of Neo4j. And one of the cool things is it includes a developer's copy, free to use, of Neo4j Enterprise Edition. So developers who are familiar with Community Edition can also use Enterprise Edition capabilities for their personal development using the desktop. And this is really a model that you can expect us to continue to invest in as we move forward. Another area that we invested very heavily in throughout the course of the end of 2017 was investment in data science and delivering the data science algorithms, and we continue to move that work forward. You'll see over the course of the summertime, we've got even more announcements and capabilities coming out around that. But these algorithms are really focused around, one, community detection, right? This identifies clusters of linked and graph items, centrality, and identifies the density of highly and loosely connected items within that community, and then pathfinding, the ability to identify traversals across those clusters or those environments is also built into these data science algorithms. So just to quickly review the kinds of capabilities that we put into the environment overall, this is really the kind of the universal feature list of what we put into Neo4j 3.3 from data integration. We also introduced the Neo4j ETL capabilities. We introduced the database itself was twice as twice as fast as or 50% faster in writing. There was capabilities we did around that. And discovery and visualization was paying acknowledgement to mostly our partner capabilities, but we'll talk some more about capabilities we've done here as well today. So let's look at 3.4. This is going to be the fun stuff. First new capability in 3.4 is we've added new data types into the environment, and there's two sets of data types that we're now supporting. The first one is geospatial search capabilities. So this allows you to put in Cartesian latitude and longitude type information, as well as distance or your radial distance kinds of capabilities around those points points on the globe. So if I wanted to figure out where the particular, let's say, coffee shops within 100 meters of my location were, I would write a query that is something akin to this, where my latitude and longitude are identified here within the query itself, and then it would tell me exactly where those particular environments, where those particular shops were. But what's really cool about it and interesting about this is the fact that we've also added a third dimension, height or depth, to this type of query. So now you imagine a type of query that we could run that might be something to the effect of, help me find a department store and locate within that store the men's clothing department, so that I can replace the shirt I've just spilled coffee on. So I could do a location-based search and identify where the department stores themselves are. I can then, it could tell me exactly which floor the men's department might be within that building, and exactly target me to the exact rack as to what my particular shirt size might be. So this is the kind of the painting of the illustration of the capabilities that we can support now using this geolocation capability. Now, I don't have slides on this, but the other element that we added to this was date time support data types. So this is attempting to be very, very similar to other popular database date time typing. So months, timestamps, and the like are now supported inside of Neo4j. So I know folks are very excited about that. So let's talk about scale. The next iteration, the reason why I put up the multi-data center capabilities is now we've added to that, we're calling this multi-clustering, and this is the ability to build an application that contains a cluster of clusters within Neo4j. So you can and this gets us into our very, very first opportunity to start to partition a graph and break it apart, and based on a particular top-level domain indicator or routing mechanism. So we can horizontally partition a graph by a domain, and we're expecting popular ones to be by country, or by product ID, or maybe customer ID, by data center. Those kind of things are what are going to allow us to then route a query to the appropriate cluster that is driven by that or identified by that top domain. So this helps support multi-tenant environments. So organizations who are want to build a secure, dependable cluster for a particular customer or a particular tenant in your environment, you can now do that. It supports geo-partitioning, so if you have to partition out your data based on location of residency locations where the data is residing, we can do that now using this multi-clustering capability. And it, of course, also supports very, very high degrees of write scaling across the environment, and really is the first the first or next movement that we've been making towards a full partitioning or full sharding kind of capability in the environment. So, and as you know, the way that Neo4j approaches moving all of our product lines forward is incrementally making improvements to towards many long-term goals, and certainly this is horizontal scaling is one of those long-term goals. Um, Next up is performance improvements across the product. And here you can see that from 3.2 to 3.3, Neo4j was like 10% faster. Now you can see that writes and Neo4j is expected to be 70% faster than 3.3. So noticeable improvement in overall performance for the Cypher runtime. And this is simply by focusing on continuous improvements inside the Cypher interpreter and the Cypher runtime environment. We've gotten great gains there. We've also been focusing for many years on supercharging the writing activity to Neo4j. And what's turned out is we looked at what overall within the environment, there's one common library that was apparently the bottleneck for 80% of the transactional write overhead was due to one particular item, and that was inserting indexes within the environment. So to address that, we've gone through a number of exercises to improve the indexing mechanisms within Neo4j. So the first was label groupings in 3.2. Then there was building native indexes for numeric items in 3.3, and now we're covering strings in 3.4. So now that we have native indexes for strings, numerics, and you'll see composite indexes is very likely the next set of items that we'll be building native indexes for. But the results are really pretty astronomical. So 10 times faster writes. Everything, of course, is going to be ACID transactions in creation of these indexes, and supports very fast read activity. But let's look at what the overall impact of this is from the point of when we introduced this. So we look at 3.4, its overall base level performance, and you can see when we added the top level blue line is when we added the native string indexing capabilities into the environment, and we saw a 500% or 5x improvement in write throughput and write performance. So I think folks are really going to enjoy the fact that our engineering staff have been really focused on eking out the best and optimizing the overall environment for Neo4j. So now let's do a quick review of what I just went through. From 3.3 onward, right, there's a huge number of performance bumps that we've been putting into the environment, and the gains that you can see that we've been getting. So even through 3.3, it was 55% faster than 3.2, and roughly 4 or 5 times faster than Neo4j 2.3. So the database itself as a whole keeps getting faster and faster, as we look to these different areas as to where to fix the most egregious bottleneck at any given time. Operationally, there's a number of new capabilities too that we put into the environment, including a new security feature called property blacklisting. This is the ability to hide a property based on a user or role. So if you didn't want to include the social security number, for example, access to that, you could blacklist that property, and a user or a role would not have that property available to them. So this extends the amount of and number of securing capabilities that we put into the environment, including wire encryption, user and role support inside the database, directory integration, event logging, Kerberos certificates. All of these are capabilities that you would really expect out of enterprise capable database environments. And Neo4j continues, as I said, to keep knocking down these critical capabilities for enterprise organizations and enterprise deployments. Last one I've got here is we've also added support for rolling upgrades. So from 3.4 onward, you now have the ability to roll the upgrade without having to turn off your database in most cases. And it makes for a much more pleasant upgrade cycle for Neo4j. So now, zero downtime, and whenever you might have to upgrade perhaps the core database store, this is the only piece of the product that you might need to have to restart in order to take on new capabilities, but you can install all the new software in the rolling upgrade manner here, and then plan out when you want to bump the servers to take on the new features and new capabilities. So really convenient item here for organizations. And then the last one is auto cache reheating. So you know what, every time that you bring up a Neo4j server, it takes some time for the server itself and the cache to get warmed up and operate at its optimal capacity. What we're doing here, whenever you restart a server, whenever you bring a server back online from backup, whenever you add a new server to the environment, will automatically heat the cache for you so that it comes up to temperature or performance as fast as it possibly can. So that's true for restarts, it's true for restores, it's true for cluster expansion, et cetera. So if we look at the overall sets of features that we put into 3.4 by edition, our different data types are in there. The performance improvements for both from native string indexes as well as Cypher. The bulk importer now supports over 100 billion objects in import, and when you run that, if you've got Enterprise Edition, you can stop and resume this feature. And then, as we said, multi-clustering, cache warming, the rolling upgrades. You can resume a cluster restore when you're bringing a new cluster member online. We've got new diagnostic and dump tool capabilities, so that if you have a particular issue and you need support, your ability to offer, what really happened kind of evidence to our support team has been improved, and that security capability, as I mentioned. So this is what the new capabilities look like here at the timing of summer 2018. Now, finally, the next thing I want to introduce is an overall brand new product in the platform. This is Neo4j. Here we go. Let's see if this is going to come up correctly. Ready, set. We'll bring on Neo4j Bloom, and this is a brand new business user or codeless environment that allows a user to drive and explore a graph simply based on search terms that they put into the environment. And you can see, even from its animation here, this bloom effect is really what brought on its name, in addition to, of course, paying homage to, let's say, early software development tools like even when Lotus came out with the spreadsheet, or Rational Rose came out with the first sets of software engineering and development tools. So Bloom itself is a very high fidelity graph navigation environment. It actually allows you to navigate different scenes, or as you're discovering performing discovery exercises within the graph, you can identify, pan, zoom, select different nodes in the graph itself. It allows you to edit and review properties of an item in the graph. It lets you color code different node categories, or even iconify different node categories. You can pan, zoom, select, identify paths within the environment. Really a very fun tool to use for folks who don't know Cypher, and for folks who either have yet or need to enjoy their explore the graph and figure out what their particular graph epiphany is going to be. So Bloom has been announced. It is not yet shipping. It will ship in June, towards the end of this quarter. So we needed to lay the groundwork with 3.4 as its foundation, and then we are in late stage beta testing and demonstrations of its functionality right now. But it's looking really good. It will be an add-on to Enterprise Edition, and certainly contact your local administrators for more information on Neo4j Bloom. It's getting really well received as that kind of storyboarding tool to allow non-technical users to also communicate with their technical compatriots when they're building or exploring a graph.